What is the blockchain? Blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. A blockchain is essentially a digital ledger of transactions that is duplicated and distributed across the entire network of computer systems on the blockchain. Each block in the chain contains a number of transactions, and every time a new transaction occurs on the blockchain, a record of that transaction is added to every participant's ledger. The decentralized database managed by multiple participants is known as distributed ledger technology. Blockchain is a type of DLT in which transactions are recorded with an immutable cryptographic signature called a hash. Each block stores three items: data, the hash, or also known as a key, the hash or key of the previous block. The properties of distributed ledger technology. Programmable. A blockchain is programmable. Secure. All records are individually encrypted. Anonymous. The identity of participants is either anonymous or pseudonymous. Unanimous. All network participants agree to the validity of each of the records. Timestamped. A transaction timestamp is recorded on a block. Immutable. Any validated records are irreversible and cannot be changed. Distributed. All network participants have a copy of the ledger for complete transparency. If one block in one chain was changed, it would be immediately apparent it had been tampered with. If hackers wanted to corrupt a blockchain system, they would have to change every block in the chain, across all the distributed versions of the chain. Blockchains such as Bitcoin and Ethereum are constantly and continually growing as blocks are being added to the chain, which significantly adds to the security of the ledger. The simplest way to explain blockchain is as a series of data blocks, each containing a unique hash number and a link to the previous block. Each block forms a vital part of the record sequence and cannot be changed. If the hash sum would change, then the altered block isn't valid anymore. This immutability is a cornerstone of blockchain security, together with three other aspects that we'll explore below. Blockchain transactions are also secured by cryptography. Each transaction is signed with a private key and then can be further verified with a public key. If transaction data changes, the signature becomes invalid. As a result, the block is ignored and won't make it to the chain. Most blockchain networks are decentralized and distributed. A system without a single point of failure is much harder to corrupt, as a hack into one part of the system will not affect others. Each blockchain works through a consensus model that verifies that a transaction has happened and is legitimate. Common consensus protocols include proof of work, proof of stake, proof of authority, and more. Blockchain has extended its reach beyond the alternative payment system behind tokens currencies, like Bitcoin, to a concept that will disrupt the entire IT landscape. The three major IT services that will be disrupted this year: storage services, database services, and cloud server infrastructure. Blockchain transactions don't require intermediaries. Processes can be made more efficient and cost less. The cost just comes out of the process instead of having a centralized service provider involved. This can cut expenses up to 50%. Blockchain-based cloud services provide speeds up to 10 times faster than current conventional technology. Fewer people in a transaction means less risk that something could go wrong. Only end users with client-side encryption have access to encryption keys and unencrypted files, a protocol that provides the data owner full control over who has access. With the sharding method, every block holds the hash or key to the previous block, which creates the chain. This method makes it more secure than current conventional practices, which is where it gets its name, blockchain. Blockchain doesn't just apply to documents. It can be used with any kind of digital asset, such as images, video files, and email backups. So, in conclusion, the blockchain has a solid future in ECM.